Question says draw the structures of major monohalo products in each of the following reaction. Okay, in these chemical reactions we have to form a major monohalo products, means a product will have one halogen. Okay, let's complete these reactions one by one. We have the first reaction, you can see cyclic ring is there, and here we have OH attached. You can see this is secondary alcohol because OH is attached to secondary carbon. Okay, second degree carbon, and it is reacting with halogenating agent SOCl2. Okay, we have other halogenating agents such as we have PCl3, PCl5 and SOCl2. Obviously SOCl2 is considered one of the best, one of the most preferred halogenating agent, because when the reaction completes, byproducts are in the gaseous state and these gases will escape automatically, leaving behind main product. Okay, leaving behind main product. Now pay attention carefully. These agents, you know what they do exactly? They will remove OH and attach Cl. Okay, OH is displaced by Cl. Okay, these are the halogenating agents, so they will introduce halogen. So we remove OH and in place of OH we attach Cl. Okay, you can see halogenation of this cyclic ring has taken place. Now you can see one oxygen, this SO will combine together supporting the entropy and we got the gas. Here still one halogen is left and this hydrogen will combine together forming HCl gas supporting the entropy. Okay, as the disorder increases, system becomes spontaneous. So automatically these gases will escape, leaving behind this major product. Only one product is there. Okay, byproducts escaped. That's why this is considered one of the most preferred halogenating agent. Move on to the next reaction. In the second reaction, you can see it is quite interesting reaction. We have benzene ring, and in this case we have N2O is there, N2O, and this is what we have CH2 and this is CH3 is there. Pay attention carefully. You can see it says Br2 is there, but reaction is taking place in the presence of UV light, means this reaction taking place in the presence of sunlight, and reaction taking place in the presence of sunlight is always completed via free radical mechanism. It means that this reaction is not going to be electrophilic substitution reaction. Okay, electrophilic substitution reaction. If in case it is a electrophilic substitution reaction, we take the region, this is what Fe and it is Br3 and then it is Br2. Okay, if this reagent is given there, then you should complete the reaction based on electrophilic substitution reaction. And if UV light is there, Br2 is there, then this reaction will be taking place via free radical mechanism. So this difference you should keep in mind. Okay. Now from here we get a Br dot, and this is what we have, Br dot, free radical generated, equal distribution of electron. Okay. Now if we talk about the stability of free radicals, you know, so stability of free radicals is done based on the stability of carbocation. And about the carbocation, we have learned that tertiary carbocation is more stable than secondary carbocation, and secondary carbocation is more stable than primary carbocation. Similarly, tertiary free radical is more stable than secondary free radical, and secondary free radical is more stable than primary free radical. Okay, that's why we always form the product based on more stable free radical or more stable carbocation. Okay, now pay attention carefully. If I remove one hydrogen from here, let's say it is going to be C, we have CH2 and H dot dot is there. This carbon is a first degree carbon, so primary free radical we got. And in case if I remove hydrogen from this carbon, so you can see one dot and H dot will get. So we get second degree carbon, second degree free radical. Second degree free radical is more stable than first degree free radical. That's why the product formation, see question says form the major monohalo product. That's why we should focus on second degree free radical carbon. From here we should form the product. If I consider, we'll get minor product because it is less stable. This carbon is more stable. That's why you can see one Br dot will connect to this Ch dot and one Br dot will connect to this H dot. From here we can remove HBr and final product we get, this is benzene ring is there. We got N2O and 2O, and this side we got CH and it is Br and this is CH3. We have to form the major product. This is major product. Okay, so based on the stability of the free radical we decide the final product. So this reaction is quite interesting because you can see via free radical mechanism this is electrophilic substitution reaction. This is considered as halogenation reaction, halogenation of benzene ring. Okay, next, third reaction. We have this reaction is also quite interesting. Benzene ring is there. This is OH having the lone pair, and then we have CH2 and it is OH is there. Okay, and we have a strong acid and little bit heating is done. A strong acid, so high heating is not required. A strong acid, automatically rate of reaction will be quite high. Now question arises here. You can see logically if you see OH remove, here also OH and H remove as a water molecule, but in which case which OH can be removed easily? This is what you have to think, this OH or this OH. And whenever the benzene ring is there, always think about the conjugated system. If the conjugated system is there, resonance is there, and if the resonance is there, stability will also be there. Okay, so now you can see here we have double bond, single bond, lone pair is there. Double bond, single bond and lone pair. These are the lone pairs we have. About the conjugated system we have learned double bond, single bond, double bond, double bond, single bond, lone pair, double bond, single bond, positive charge, double bond, single bond, negative charge. If these four cases are there, definitely conjugated system is there and resonance is also there. You can see here we have the resonance. So this electron density will move this side like this. So partial double bond will be generated. Here we have the partial double bond will be generated. If the partial double bond due to the resonance is generated, stability of this bond will be increasing. Hence breaking of this bond is not so easy. That's why removal of this OH from this benzene due to the generation of the partial double bond is not easy. Okay, now in this case if I talk about, let's say if I break this bond, so it will carry negative charge and it will carry positive charge. Now you can see double bond, single bond, positive charge. It is a conjugated system. Double single positive charge, double single negative charge, double single lone pair resonance. Okay, so you can see by removal of OH, its stability is increasing because once we remove OH, you can see it is carrying positive charge and this positive charge is a part of resonance. You can see double single positive charge. So removal of this OH is much more easier in comparison to this OH because in this case the system is going to be unstable. Okay, and in this case system is becoming more stable. Now this is strong acid is there. From here easily we can get H plus ion is there. A strong acid will liberate H plus ion, OH minus ion, H plus ion will remove H2O. You can see remove water molecule, and from here this Cl minus, it is carrying positive charge, it is carrying negative charge. This negative charge will be attracted by, you can see most stable carbocation stabilized by resonance. We get the product. This is benzene ring is there. This is what? Sorry, OH. It is OH, OH, we have OH, and this side we got CH2 and this is Cl. This is the major product. Okay, now move on to the next chemical reaction. We have the fourth chemical reaction. You can see benzene ring is there. Oh no, sorry, there is no benzene ring, only one double bond system. This is what we have, CH3 is there. Okay, cyclic alkene is there, double bond is there, and reacting with HI is there, hydrogen halide, hydrogen iodide is there, hydrogen iodide. Okay, now alkene reacting with hydrogen halide, how we complete the reaction? Via Markovnikov rule. Okay, via Markovnikov rule. Now pay attention carefully. You can see from here, if I break it, it will carry positive charge, it will carry negative charge. And according to Marconi rule, anion will go to the carbon having less number of hydrogen. In a double bonded system, you can see this is a double bonded system. Here, if you talk about this carbon does not have any hydrogen because this carbon is already forming how many bonds? 4 bonds. You can see 1, 2, 3, 4. It does not have any hydrogen. And this carbon, you can see forming 3 bonds. 1, 2, 3 means 1 hydrogen is present. 1 hydrogen is present. It means anion will go to the carbon having less number of hydrogen. This carbon has 0 hydrogen, this carbon has 1 hydrogen. So I minus will attach to this carbon, H plus will attach to this carbon. Okay, we are completing this reaction according to Marconi rule. So let's form the product. We have the cyclic ring is there. This bond is broken. Now this is alkyl group, and to this carbon I will attach. This is what we have, iodine. Okay, H will combine here. That is the final product. Okay, based on Marconi rule we completed. Move on to the next reaction. Fifth reaction, we have CH3, CH2 and then Br is there. Okay, reacting with NaI. Okay, they have not mentioned solvent, there should be acetone and little bit heating is there. Okay, you can see this is halide, this is also halide, means halogen exchange reaction, and this reaction is known as Finkelstein reaction. Finkelstein exchange of halogen. And in this case, what is the condition? Keep in mind the halogen attached to the carbon chain should be more electronegative, and this halogen attached to the metal should be less electronegative. Then halogen exchange takes place, otherwise halogen exchange does not take place. This is the condition. Okay, so what will happen? Br will come in place of I, and I will go in place of Br. From here we can remove NaBr, and we get the product. This is what CH3, CH2, and we have I is there. This is the major monohalo product. Only one halogen is attached. Okay, the name reaction Finkelstein reaction, halogen exchange reaction. Move on to the last reaction. So we have sixth reaction is there. So in this case you can see cyclohexene is there, cyclohexene, and it is reacting with Br2 halogen. Br2 is there, and UV light is there. UV light means again this reaction will be taking place via free radical mechanism. Okay, from here we can get the free radicals of Br dot. We got Br dot, and here also we got Br dot. And keep in mind, you cannot break the bond and attach Br here, Br here. You can see in the presence of sunlight, this bond cannot be broken because bonding strength is quite high. Okay, you cannot break this bond because reaction is taking place at the room temperature in the presence of sunlight. Okay, and as we have learned in the second reaction, in case of free radical mechanism, when the reaction is taking place via free radical mechanism, we always form the product from the more stable free radical carbon. Okay, tertiary free radical is more stable than secondary one. So you can see here all these carbons are secondary carbon, secondary. But these two carbons will not be participating in the reaction because room temperature is there. Go to the next carbon. Here we have hydrogen is present. This carbon is forming 2 bonds, hence 2 hydrogen are there. Similarly, this carbon is also forming 2 bonds, 2 hydrogen. This carbon and this carbon is same. But question arises here, why I need to select this carbon? Keep in mind, you can see if I break this bond, equal distribution of the electron is there. So H dot will be there, and this is what we have, C dot is there. Okay, C dot. Now, for example, let's say for a moment, if I consider it is C plus, so double bond, single bond, positive charge, because the stability of free radical is completely equivalent to the stability of carbocation. So you can see double single free radical, double single electron, double single negative charge. Electron is having what? Negative charge. So you can see resonance will be there. If I remove hydrogen from here, dot and dot, so you can see this dot is not in the resonance with respect to this double bond, because double bond, single bond, and then single bond, there is no conjugation. There is no conjugation. Here we are getting conjugation, double bond, single bond, electron. Okay, here also you can get, so from here also you can remove the hydrogen. You cannot think about removing hydrogen from this carbon and this carbon because it is not a part of conjugation. So that's why you can see H dot Br dot will remove as a HBr, okay, and Br dot will combine with this C dot, then we get the product. Double bond will be there and Br you can attach. Instead, if you select this carbon, so you can see Br will be at the bottom. We have to introduce only one Br. It says major monohalo product, only one Br. One halogen is introduced. Okay, so that is the final major product. If you like this video, please share and subscribe to the channel.